Dear Miss Manners, is it proper to lick Taki's dust off one's fingers at the dinner table? Asking for a friend, Stu.
Hey, buddy, what are you doing?
Well, I was just writing a letter to Miss Manners.
Miss Manners? Why?
Well, because you said we were having a lesson on manners today.
I did? When did I say something about manners?
You were talking about proper and improper.
Oh.
I figured I would ask, because you've been complaining lately about Taki's finger licking.
So let's take this one at a time, okay?
Yeah.
You absolutely should be writing letters to Miss Manners because you have a lot to learn.
What?
That is a reasonable self-betterment task for you to undertake, and I support it.
Well,
okay?
I was just going to use it against you when she told me I was right.
She's not going to take your side.
What?
Yeah, she's a very proper person.
Oh.
And that brings us to the second point.
What?
Which is that we are going to be discussing proper and improper fractions.
Oh.
Because that's going to relate to mixed numbers, which we are also covering today.
So this is not a lesson on manners.
I mean, it's always good to learn about manners, but no, not specifically. This is going to be a lesson on fractions, and we're really going to focus on mixed numbers.
Okay.
Yeah.
Later, Miss Manners.
Okay. So, like, you just throwing a piece of paper on the floor? Not great manners.
No, but I was done with it.
Is the floor where we put things when we're done with them?
My clothes, my shoes, my backpack. I'm guessing, though, the way you look, the answer is no.
It's amazing how intuitive you can be just from certain looks, and yet you still don't do the right thing.
Maybe we do need a lesson on manners.
Maybe we do.
I need a sticker chart.
Tune in next week for Mr. Manella's etiquette class. Okay.
Okay, but today we're going to do fractions.
Right. So a proper fraction is really just a fraction where the numerator is smaller than the denominator. It's just a typical fraction. We don't really call them proper fractions. We just call them fractions. Okay? So like 1/2 is a proper normal fraction. Okay?
Okay.
2/3, however you want to look at it. Okay?
So you can call it a proper fraction or just fraction.
Yeah, we would just call it a fraction. Okay?
Okay.
And you can call it a proper fraction, that's fine.
Okay.
But an improper fraction is a fraction when your numerator is larger than your denominator. Like, let's say we had 3 halves. Do you know what that would mean when your numerator is bigger than your denominator?
Hold on, let me think about this. Well, 2 halves would be a whole. Right? So if you had 3 halves, it'd be like having a whole pizza and another half a pizza?
Right, so would that be more or less than 1 pizza?
More.
Right. An improper fraction means your fraction is bigger than 1 whole.
Oh.
Now, that can be a very big number. Like if we had 33 halves.
Whoa, so much pizza.
That would be like 16 pizzas. 16 and a half pizzas. Okay, but we're getting a little ahead of ourselves. Let's go back and look at 3 halves, okay?
Okay.
You said it would be like 1 whole pizza and another half of a pizza. Well, to figure out exactly what that is, so we would take the 2 halves out, because that's our whole, right? And then we'd have 1/2 left over. So we would have 1 whole and 1/2. And that would give us a mixed number called 1/2. Yeah.
Okay, so wait. You have... Oh, I can use my pen as a poker.
Can you? Your noodle arms aren't exactly working in that regard. Let me help you.
It's not working. Okay, I got... Show me the mixed number, right?
Oh my God, you're growing a human hand out of your stomach.
No, what? Oh, the magic is gone. It's all gone.
Well, we can keep going.
The man behind the curtain is exposed.
Actually, that was my hand. This is this one back here. I was just trying to support
Yeah, it's totally Mr. Renella's hand. He was helping me out.
Yeah, it's fine.
All right.
Again,
mildly embarrassed.
We are not professionals.
Okay. All right. Well, I just wanted to point out that there was a mixed number and point to it.
This one?
Yes.
Yeah,
man, you just need to be the pointer.
Yeah, I can do that.
Okay, so that one is a mixed number.
It is. A mixed number is a number that has a whole number part and a fraction part.
Yeah. Okay, and then you have an improper fraction.
Which
point
means
to that one.
Bigger numerator than denominator.
Okay. I was just trying to get everything straight.
It's good. Okay.
Okay.
So
okay.
when you have an improper fraction, oftentimes you have to turn that into a mixed number. And the way you do that is really you're just dividing the numerator by the denominator. That's what a fraction is. It's a division problem, okay?
Oh, yeah.
So if we have 5 halves, okay, that means that we're really doing 5 divided by 2. How many 2's fit in 5?
Well, 2.
2.
And then you got a little left over.
Then we practice our long division, right? We subtract. And our remainder is 1. But what our remainder really is the numerator part of our mixed number. It goes here. And our denominator is the number of pieces to make one whole.
So 5 divided by 2 is actually 2.5.
It is, yeah.
Oh! I kind of remember this when we were talking about division, but now it's starting to make more sense.
Yeah, so you can turn any improper fraction into a mixed number. Now, one of the reasons we're talking about this is that we're going to be adding mixed numbers today. And sometimes when you add mixed numbers and they both have fraction parts, those two fraction parts can add up to an improper fraction. And you can't have a mixed number with an improper fraction in it. Like you can't have 3 and let's say 4/3 as an improper fraction because there's one whole hiding in here.
Oh.
And we have to make that one whole number go with the other whole number.
Right, like you got to put together all the whole pizzas and find out what you got left over.
Right. So
that would be like how many whole pizzas?
So like, well, how many pieces make a whole here?
3.
Right, so we can take those 3 pieces out, take those 3 away from 4, and what's left?
Well, just 1 piece.
Right, there's that 1/3 left, and we take those 3/3, which is 1 whole. That's what we took out, right?
Yeah.
And we're going to add them up to here.
Oh.
So we're going to add 1 whole, 1, onto 3. What's 3 plus 1?
Well, that's 4.
It's 4, and then we keep that 1/3 next to it.
Oh. So 3 and 4/3 pizza would really just be 4 pizzas and another third of a pizza left over.
Right. You got to take out any whole numbers in the improper fraction.
Pull out the whole.
And put them onto the whole number itself.
Okay.
So, and if this seems a little bit confusing,
a little bit,
we're going to cover more of it in the lesson that's coming up. We got a lot to cover. This is going to be a long lesson.
Yep.
But that's all right.
Manners.
Because it's important. Yeah. Be polite.
Yeah.
Okay. Let's take a little break.
Yeah.
And then we're going to come back to the whiteboard and check out some new problems.
Okay.
All right?
Yeah, I'm going to get rid of this pen.
Yeah, it's clearly in your way.
Yeah.
Okay. We'll be right back. Okay, so when we add mixed numbers, there are a couple different scenarios we can come across. The most basic is when there's only one mixed number in the addition problem. And then all we need to do is add the whole numbers and carry our fraction part along for the ride. Okay?
Oh.
So what's 3 plus 2?
Well, that's 5.
Okay. 5. Bring the 1/2 over. That's it. We're done. It's 5.5.
Yeah. This is kind of like the mental math where you're like, just do it in chunks.
Right. So when there's no other fraction part tag, there's like 0 halves here. There's nothing there. It's a whole number.
Yeah.
So we just bring that over. Okay?
Yeah.
Let's try one more of these, and then we'll move on to a different type because we're going to get progressively more complicated as we go.
Okay. Leveling up.
We are leveling up. So let's say 7 plus 11.
Okay.
Oops, that's not very neat. 11 and 2/3. Okay, what's 7 plus 11?
18.
Yeah, and then bring your fraction over and you get
2/3.
2/3.
Just plop it right over
18 and 2/3. So if one number doesn't have a fraction part, then you just leave the fraction part alone and you just add the whole numbers.
Right.
Okay?
Kind of like if it was like a decimal.
Yeah, kind of. Like if you did like 3 plus 4.5, it would just be 7.5.
Yeah.
Okay, you wouldn't have to worry about the decimal part because the fraction and the decimal, they're the same thing.
What?
They just dress differently. You know. Okay.
Ah.
Let's go on to the next concept.
Okay.
Okay, so now we have 2 mixed numbers that we're going to be adding to each other. So, the first thing you can do in this case is go ahead and add the whole numbers. Just like we did in the last problem, but then we're going to have to add the fractions. What's 6 plus 2?
That's 8.
8. We're going to save that for later. Put our 8 there. That's going to go on our answer. Okay? Now, here I've got 2 and 5. Well, so I've got 1/2 plus 2/5. Now, we need to do what we learned in the last lesson and add them to each other. Now, can you turn a 2 into a 5? Because that needs to be the first question you ask yourself, right?
Yeah.
Can I turn the smaller denominator into the larger denominator? Can you multiply and turn a 2 into a 5?
No, you cannot.
No, you cannot. Okay, so that we're going to have a new denominator. We're going to get a common denominator. So
lay out your problem. You always do that so nice.
What is 2 times 5?
10.
So 10 is going to be our new denominator.
Yeah, because we're cross multiplying.
We are going to cross multiply. So we got a color code. Okay.
Yeah.
Now, if you don't have a lot of different colors at home, that's fine. But I'm doing this so you can see exactly what steps I'm doing.
I love it.
How did 2 turn into 10?
We multiplied it by 5.
We did. So we're going to do the same thing to the 1.
Oh, it's just 5.
It is just 5. Okay, that came from there, remember?
All right.
Now,
yeah,
we're going to do, how did 5 turn into 10?
Well, we multiplied it by 2.
We did, so we're going to do the same thing to the 2.
Okay, well, that's going to be 2 times 2 is 4.
Right, remember, it's not always a 1 up here. You can't just put a 2 here because you're multiplying by 2. This is a 2, and that's the thing you've got to multiply by 2. Okay? So now, we've got 5 tenths plus 4 tenths. And how many total tenths is that going to equal?
Well, that is 9 tenths.
It is 9 tenths. So that 9 tenths is going to go up into our answer with the 8. So we'll have 8 and 9 tenths, and that'll be our mixed number.
So like this is one of those times you have to use your workspace under a problem.
Yeah.
Right? You got to do this other little problem, and then you put it back together up there.
Yeah, there's a lot of steps. It's like doing a complicated Lego piece. Like, you got to put everything together. And so if you follow the directions, it'll turn out right.
Yeah.
But if you don't, you might have a mistake. You might lose a couple Lego pieces, and then all of a sudden your battleship doesn't work the way it's supposed to.
So you got to show your work right there.
Right. Let's do one more of these.
Okay.
Okay. I feel like we're not deploying your nose as an eraser often enough. Okay?
Oh, no, man. I don't want to erase that dust in my nose. I do think my nose makes quite a beautiful shadow, though, on the whiteboard.
It is really something.
I've been watching the videos.
Yeah, it's like it's our own little kind of theater.
Yes.
Okay, so now we're going to add the whole numbers first. What's 4 plus 8?
12.
It is 12, okay? And now we have to add our fractions. We've got 5 twelfths plus 1 fourth. Now, can we turn a 4 into a 12?
Yeah, you can if you multiply it by 3.
Okay, so that means 12 is going to be our denominator.
Oh, okay, and it goes in the first spot because it was first.
Okay.
So,
well, yes, this 12 did not change his pants, which means its shirt is going to stay what?
Stay the same.
It's going to be a 5 still. That part didn't change, okay?
Yeah.
If you don't change the pants, don't change the shirt.
Yeah.
Okay, now this one, how did this 4 turn into 12?
That 4 changed its pants by multiplying by 3.
Correct. So we're going to do the same thing to the numerator.
Yeah, times 3. Change that shirt.
Okay, and now we can add 5 plus 3. What's 5 plus 3?
8.
It is
12ths.
It is 8 twelfths. So it's 12 and 8 twelfths. And that's our answer. Okay? Now, these were 2 problems that did not involve improper fractions.
Yep.
The next 2 we do are going to involve improper fractions, which is going to involve regrouping of whole numbers. Okay? But we learned about that at the beginning of the lesson, and now we're going to revisit it. You ready to revisit some improper fractions?
Yes. 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 Yes, I am. I was not sure at first, and now I am.
Good.
I am ready.
Good. Okay.
Yes.
Let's do that.
All right.
Okay, so now we're going to be adding 2 mixed numbers, and the fraction parts together are going to be more than 1, okay, when they add together. So then we're going to work on regrouping that, and then adding the whole that we pull out of it, the whole 1, onto the whole number part. We're still going to add our whole number parts first, okay? So,
all right.
What's 5 plus 3?
8.
8.
Man, we're really leveling up here.
Yeah. No, this is
highest level.
This is one of dealing with mixed numbers is one of the hardest things about 5th grade math. So if you can handle this, you can handle anything 5th grade math's going to throw at you. Okay?
Take us through it.
Okay, so now we're going to add our fraction parts. Can you turn a 4 into an 8?
Yeah, I can.
Okay, so 8's going to be our denominator.
Yeah. Yep.
Okay, so this 8 did not change, which means this 7 is not going to what?
Oh, it's not changing either.
Nope, it's staying the same.
Yep.
Now.
But the 4 changed.
How did 4 turn into 8?
We multiplied it by 2.
Sure did.
So we have to do the same thing to the top.
And what's
the
3
numerator?
3 times 2?
It's 6.
Okay, now it's 6 plus 7.
It's 13.
It is 13.
Wait, 13 eighths. It's improper!
It is improper, which means we need to take the 1 whole out and put that onto our 8 here. How many eighths make 1 whole?
8 eighths.
So we need to take those 8 eighths out, okay?
Okay.
Which would leave us with how many eighths?
5.
It would leave us with 5 eighths.
Right.
Now,
because 13 minus those 8 eighths.
Right,
be
that's
5.
the 1 whole. Now, we're not getting rid of that 1 whole. We're regrouping it onto the 8. So take 1 whole and add it onto 8. 8 plus 1. What's that?
9.
So we change that into a 9.
Okay.
And now we still need to bring these 5 eighths along for the ride.
Whoa. Okay.
So it's 9 and 5 eighths.
I almost feel dizzy. So much just happened.
So it was 8 and 13 eighths. We took 1 whole out of the 13 eighths.
Okay.
Put it onto the 8, which gave us 9. And we still had those 5 eighths left over. If you think of it as a division problem, we took 13 and we divided it by 8. 8 went in. Whoops, I'm not going to have room here. I need to space this out.
Oh, yeah. Use your workspace.
Yes.
You got plenty of space to show your work.
Be organized. So I did 13 divided by 8. When we subtracted those 8 eighths away, we are really dividing 13 by 8. I get 1. It goes in 1 time. 13 minus 8 is 5. And I got 5 left over. My remainder is my leftover eighths.
Whoa. Look at that.
So
that's a mixed number.
It is a mixed number. And you add 1 and 5 eighths to the 8 we had up here, and you get 9 and 5 eighths.
Well, and like if you rewrote it, it would be one of those easier mixed number addition problems.
Right, it would be like 8 plus 1 and 5 eighths, which equals 9 and 5 eighths.
Yeah.
Which, lo and behold,
yeah.
We got there like 2 different ways.
Oh, so many steps.
It is. Let's do one more of these.
Okay, definitely. Whew.
Yeah, it's a lot.
Yeah. But I mean...
You're going to get a chance to practice more, though.
We're getting through it, though.
We are. So let's do 11 and 2/3.
Okay. Let's do it.
Plus 9 and 4/5.
Okay.
So let's add our whole numbers first. What's 11 plus 9?
Ooh, 20.
It is 20. Okay, we're going to save that 20, okay?
Yeah.
So now we need to do 2/3.
Okay.
Plus 4/5.
Okay.
Now.
I cannot make 3 into 5.
Correct. You cannot, which means we're going to have to multiply them by each other.
Cross multiply.
We're going to cross multiply. What's 3 times 5?
15.
15.
Okay, 15. 15 and another 15 right there.
Yeah, you just put your nose on my marker.
I used it as a pointer.
I gotta sanitize this now. Okay. How did 3 turn into 15?
We multiplied it by 5.
Correct. So now you need to do the same thing to the numerator.
2 times 5 is 10.
It is. Now, how did 5 turn into 15?
I multiplied it by 3.
Correct. So 4 times 3 is?
12.
Remember, whatever you do to the denominator, you have to do to the numerator. Whatever you do to the bottom, you have to do to the top.
Right.
However you change the pants, the shirt needs to match.
Yeah.
Right? Even if you don't wear pants.
Yeah. Always match.
Yeah, well, when you never change your clothing. So what's 10 plus 12?
22.
It is 22.
22/15 is an improper fraction.
It is. So we're going to take, how many make a whole?
Oh, 15/15 make a whole.
We're going to take those 15/15 out.
Okay.
Okay. That's going to be our 1 whole.
Okay.
And what's 22 minus 15?
7.
It is 7.
Okay.
So that's 7/15 left over. We're going to take that 1 whole and add it on to 20. And what's that going to give us?
Well, 20 plus 1 is 21.
It is going to be 21. Okay.
Oh, and then add our little fraction.
And then our 7/15 needs to come along.
Oh.
21 and 7/15. Okay?
Yeah.
And if we divide 22 by 15.
Oh, he's going to show us.
Okay. 15 goes into 22 1 time. We subtract. We get 7/15 left over. 1 and 7/15.
There's our mixed number.
And if we
just
add
added
that to 20. Your nose is in the way. It's 21 and 7/15.
Quite a powerful schnoz.
Now,
there it is. 21 and 7/15.
Now, the nice thing when you're adding mixed numbers, if they both have fraction parts, it's never going to be more than one whole in your improper fraction. An improper fraction can be worth more than, like it can be worth 2 or 100 or 1,000,000. But in cases like this, it's always going to be one whole hiding in there. Because these two fraction parts themselves are less than 1, so they can't add up to more than 2. So,
that makes sense.
Yeah. So it's always going to be one whole and something. So here we got 21 and 7/15. That was a lot, right?
That's a lot. You know what would help, I think, if I was doing a practice page? If I had like one of these as an example, like if I put it on the top of my practice page with all the color coding, and then if I got lost, I could be like, what am I doing? And then go look at the example.
That's a good
So
plan.
you should leave this on the board for me when I'm practicing.
Okay. Well, you know, you can watch this video as many times as you need to.
I can! And see my nose!
I think this has gone on long enough.
Yeah.
It would not be very proper of us to keep students from their learning.
He brought it back around!
I shouldn't say from their learning because they're learning in the video, but from their practicing.
Yeah. Because
they need to practice.
Definitely.
Okay.
I definitely need to practice this.
Okay. Let's do a quick recap.
Okay, recap! So good, you wrote it around my nose.
All right. We covered a lot.
Yeah.
This video is already 20 minutes long. Which is,
oh!
We set a record, dude. High five!
High five!
What? We still gotta work on that. We've been working on that. To be fair, we haven't been practicing a lot. Okay.
Yeah.
An improper fraction is a fraction with a numerator that's bigger than the denominator, like 7/4.
It's got sneaky whole numbers hiding in there.
Right. And a mixed number is a number that has a whole number part and a fraction part. Okay?
Yeah.
1 3/4, 7/4, same thing. Okay?
What?
Took the 4/4 out, made a one whole, got 3 left over.
Yeah.
Okay?
Yeah.
When you're adding mixed numbers, okay? Add the whole numbers first. Then you add the fraction parts.
Yeah.
Regroup one whole if necessary. It's not always going to be necessary.
Yeah.
Okay? But if you get an improper fraction for your fraction parts, you need to regroup one whole and then put all the parts back together.
Yeah.
Okay? It's a lot of steps. It's a lot of work.
Yeah.
But if you follow the directions and you're careful, you will get the proper answer.
Yeah, you will.
Okay.
Proper. I see what you did there.
You can see the light bulb go off above your head.
Yeah, it takes a minute sometimes.
He's not a microwave.
Yeah, what?
It's more of a slow cooker.
Yeah, I'm a crock pot. Full of beans.
You're full of a lot of things, buddy.
Yeah. You know what's not proper? What you do after eating beans.
All right. This has gone on long enough.
Yep. I'm hungry now.
I'm not. This concludes our video lesson.
Hey,
See you next time.
See you next